It may come as no surprise, but I talk to a lot of people about CockroachDB, and I've realised from these conversations just how prolific the mindset of disaster recovery is when we talk about databases. Historically, zero RPO with very minimal RTO measured in the seconds just wasn't possible with the technologies available. So I can understand why customers are skeptical when I'm on the phone to them talking about CockroachDB's zero RPO and RTO measured in the low seconds, essentially outperforming their tried and tested databases of choice. In the world of DR, the two data center approach is people's go-to. For them, CockroachDB's multi-active paradigm, where 3 or more data centers would contribute to a very robust, resilient system, is quite a foreign concept. But once the penny drops that there is a better way to running a database than a primary standby infrastructure, things become a whole lot more resilient and a lot more interesting. If you're currently running a database with a primary and standby, this video is for you. It shows what your journey to CockroachDB and multi-active replication might look like, and hopefully it will dispel some of the confusion around the differences between disaster recovery and disaster prevention. We'll start from the ground up. First, I'll install CockroachDB in a single data center. Running multiple CockroachDB nodes, even if they're in the same data center, already yields operational benefits. I'll talk about those at the end of the video, but this will be our first port of call. Customers will be talking to the database via a load balancer through their application. Then we'll install CockroachDB across 2 data centers. In this example, we'll have a primary data center and a standby data center, with the load balancer routing traffic to the primary data center and CockroachDB's built-in physical cluster replication replicating data consistently to the standby data center. If for some reason the primary data center were to go offline, we can fail over to the standby data center and business can continue as normal. So that's 1 and 2. But what about 3? You might not have access to a third data center. And if so, this might be your target state. But I will go one step further and assume that maybe you have a third data center or access to the cloud. In this setup, we have a user talking to the same application and the same load balancer. I'm doing this all live with zero downtime, but this time our primary data center and our standby data center form one single cluster with an additional cloud region. This is where multi-active replication comes in. We can lose any of these data centers in their entirety and CockroachDB will continue to run. Let's stop waffling and start coding. First, I'll spin up 3 CockroachDB nodes. I'll set their locality to be primary. Their port numbers will be 26101, 2, and 3. And then I'll initialize the cluster. Note that I've got this virtualized flag here because later in the 2 data center approach, I'll be spinning up a virtualized empty cluster and replicating to that. Next, I'll run a very simple load balancer, make it aware of our 3 CockroachDB nodes, and activate that route. This is just a load balancer of my own design for this demo. You'll be using a hardware load balancer like F5 or a better software load balancer than I could create. Next, I'll create some database objects. This will be a very simple banking application with banking transfers happening. I'll generate 100,000 different accounts and I'll start a workload. I'll be simulating a number of customers, checking their balance and making transfers. The successful request counts are over here and any errors that occur will be over here. So to recap, what we have at the moment is exactly this setup. We're running CockroachDB against a single data center. In this setup, your RTO will only be as quick as your ability to restore from backup. So many of our customers running across 2 data centers prefer to use physical cluster replication, which can help lower your RTO and RPO. Let's configure the standby cluster and start that replication now. I'll start 3 new nodes with a locality of standby. The naming is arbitrary, but it's designed to help you understand what's going on. And the port numbers for these nodes are 26201, 2, and 3. And I'm initializing the cluster as virtualized empty this time, meaning it's not the live cluster, but it can be the target of replication. For replication to be possible, I have to enable range feeds in the primary cluster. And then I'll connect to the standby and start the process of replication. With this command, I'll replicate data from the primary cluster to the standby cluster. In a 2 data center world, this is our disaster recovery mechanism. And with this command, I can see the status of replication. So we're currently initializing replication, and now we've started replication. I'll wait for the replicated time and replicated lag to be populated, and that way I know how up to date my replica is. And this will always be in the order of seconds. And there we have it. We've got a replication lag of 27 seconds, and it will always remain around that area. And we can see the last time we received a bunch of replication bytes from the primary. It's worth noting that a 2 data center setup with physical cluster replication is very much in the disaster recovery operating model. If you only have access to 2 data centers and still want a high availability setup, consider logical data replication, which I talk about in this video. Going back to our diagrams now, we're now running in this setup. The users are talking to the application, which is going via a load balancer to the primary data center, with data asynchronously streaming to the standby. If anything were to happen to this data center, we could fail over to the standby and business would continue as usual. But your journey might not end there. You might wish to eventually end up with a 3 data center setup using CockroachDB's modus operandi, which is multi-active replication. Once you have a setup like this, there's no more manual intervention required in the event of an outage. You could lose nodes in each region or the entire regions themselves, and CockroachDB will self-heal and business can continue without your involvement. Let's set up a 3rd region and then move towards multi-active replication. With these commands, I'm spinning up 3 new nodes. They're running locally, but let's assume they're in the cloud. Their port numbers are 26301, 2, and 3, and they're connecting to the primary cluster. You don't need to specify all of the nodes here. I could have just specified the primary, but this will result in a 6-node cluster. I'll start this. And if I come over to the cluster overview, you'll see that there are now 6 nodes in the cluster, 3 nodes in the primary, and 3 nodes in the cloud. We currently have under-replicated ranges because CockroachDB now knows that it has more nodes to replicate across, so it's undergoing the process of rebalancing the replicas. When that comes down to 0, I'll bring the cloud nodes into the load balancer. This is a very small cluster. I'm only storing a couple of 100 megabytes of data in here. If you're running a database of terabytes in size, this process would take longer. The cluster is now fully replicated. And if we look at the node list, the replicas against the primary and the cloud will be roughly the same. Each node in the primary data center has around 50 replicas, and that's the same for the cloud. So data is now evenly spread across all the 6 nodes. And if we look at the replication dashboard, you can see that when I brought in these 3 additional nodes, the number of replicas for the existing nodes went down, and the number of replicas for the new nodes went up. They converged. So now each node has fewer ranges, and also leaseholders. These are the things that control reads and writes to particular ranges of data. Let's bring those nodes into the cluster. So whenever we talk to the load balancer, we'll now hit one of these nodes. At this point, we have our primary data center and our cloud data center acting as one cluster and still continuing to replicate data to the standby. I'll now bring the standby cluster into the fold so that we have a 3 data center setup. The way I'll be doing this is simply by turning off the standby and then restarting the nodes, but this time joining the other cluster. Let's do that now, and what we'll end up with is a 3 data center CockroachDB setup running multi-active replication. I'll kill the standby nodes and I'll delete their data, and then I'll start 3 new nodes, but this time joining the existing cluster. And if we come over to the overview, we now have 9 nodes and 3 CockroachDB regions. Because I specified locality flags of primary, standby, and cloud, this is what CockroachDB is showing. And the replicas are now coming over to the standby as well. Data is being rebalanced again, because instead of having 6 nodes, our cluster now has 9. I'll come back over to our replication dashboard. And again, you can see that the number of replicas on each existing node is coming down because the number of replicas that can be distributed across to the new nodes is going up. They'll eventually converge. And you can see this step pattern. New nodes, new nodes. And it'll be the same for the leaseholders. Those have converged now. We now have 9 nodes participating equally in the workload, so I can update the load balancer to factor in the standby nodes. And that leaves us with a multi-active CockroachDB cluster. Currently, we wouldn't survive the outage of a region, and that's because the default survival goals of a CockroachDB cluster are zonal, meaning if I were to lose a node from any of the data centers or regions, CockroachDB would continue. But if we were to lose a whole data center or region, CockroachDB would be less happy. Let's update our survival goals to achieve regional resilience. I'll connect to CockroachDB via the load balancer. And if we have a look at the regions, we have our cloud, primary, and standby regions, but they're not assigned to any databases. My workload is running against the default DB, but you could run the following commands against any database. First, we'll set the database's primary region, and I'll just set that to be my primary data center, in keeping with the way I was treating that data center in my 2 data center setup. I'll make the default DB aware of my standby and cloud data centers, make them CockroachDB regions. And while setting a secondary region is entirely optional, it gives you predictable latencies in the event that the primary data center fails. The leaseholders will move from the primary data center, which might be down, to the standby data center, our secondary region, rather than moving to the standby cluster and the cloud. This is also in keeping with the way we are treating our primary and standby data centers. But again, it's optional. Now, if we take a look at the regions, we'll see that our default DB is aware of the regions, with the primary data center being the primary region of the default DB, and the standby data center being the secondary region of the default DB. Let's now take a look at our survival goals, and you can see our current survival goal for the cluster is zonal, meaning we wouldn't currently survive an outage of an entire data center. That, however, is fixed by that command. If we look at the survival goals now, we're now surviving regional outages. Under the hood, CockroachDB is increasing its replication factor from 3 to 5 to ensure that there are more replicas available in the event that any of these data centers go down. Wherever you currently are or want to get to with CockroachDB, be that nodes running in a single data center, 2 data centers with physical cluster replication, or 3 data centers with multi-active replication, you're still gaining operational benefits over running a traditional monolithic database. You can lose, upgrade, scale, or repave your machines with zero downtime. Many of the failures that would have previously brought your business to its knees are now simply blips. Hopefully this gives you an idea as to why CockroachDB thrives with 3 data centers, but how it can just as easily satisfy your requirements of low RPO and RTO with 2.